Today's video is all about the law of sines, as you can tell from the title here on the slide. This unit, or this topic anyway, and the next one, law of cosines, are two that were added based on the CLEP exam themselves. The law of sines and law of cosines is, again, something you did last year, but as you look through and do the examples of these, it's just a healthy reminder, and these are the kinds of questions that you will see for sure on the CLEP exam. So the law of sines, first of all, it's important to notice, you can use it when you have two angles and one of the sides. So you're given a triangle, some form of fashion, whether through a word problem where they actually give you a triangle, and they say to you, all right, you have two of the angles and one of the sides, or you have two sides and one of the angles. And it, of course, uses the property of proportions and the fact that we know that the sine of an angle is equal to the proportion of sides, opposite over hypotenuse in particular, correct? And so when we use the law of sines, it deals with that proportion, and obviously in proportions. So it's a side to the sine of the angle opposite, the side B to the angle, or to the sine of that angle that's opposite that side. And of course it could be C, sine C. So let me just show you just quickly, first using an actual triangle here, and where they give it to you in this form, and then you can see where, oh, we've got it where a word problem. So, all right, we got triangle ABC. Angle A is 30, B is 50, and A equals 10, find B. Now, let me just make a note that when you're drawing these, it is helpful to not draw a right triangle. And you might say, helpful? Well, because it misleads you. If you start by drawing a triangle and immediately just draw a right triangle, it's going to kind of mess you up as you're doing this, okay? So, because you're just mentally think that it's going to be 90 degrees. So my suggestion to you is just to draw an obtuse angle and draw the sides, okay? And so we have angle A, we have angle B, and since I know that A is 30, then I know that it's not going to be the obtuse one, right? And I know B is 50, so I'm going to draw a 50 in here, and that would be angle C, of course, because it's triangle ABC. Side A equals 10, and of course side A is opposite angle A, and it asks us to find B. So truth be told, you really didn't even need C, but we could find angle C, right? Because we know that all three angles in a triangle add up to 180. Let me reiterate that it's the angles that add up to 180, not the sides. Angles add up to 180 degrees. All right, so to do this problem, it's pretty simple here. You have 10, which is A, and the sine of A, and of course that angle is 30, is equal to B, which we don't know, sine of 50, which is the angle B. And then you would cross multiply, so you would have 10 times the sine of 50 equals B times the sine of 30, and sometimes you'd write the sine of 30 times B. So what we're going to do is we now just need to solve this. To solve for B, you would divide by the sine of 30. Pay special attention to the fact that these are in degrees, and so in solving for B, you need to make sure that your calculator is in degree mode, and then you basically just type it in as you see it. 10 times the sine of 50 divided by the sine of 30. And just using my calculator here, I have 15.320888886. And of course, it would tell us what we needed to round to, or we'd look for the choices that looked close to that, approximately. Here's a word problem. Bill determines that the angle of elevation to the top of a building measures 40 degrees. If he walks 102 feet closer to the building, the measure of the new angle of elevation will be 50 degrees. Find the height of the building. All right, so we've got Bill. Got a little hat on. All right, he is looking to the top of a building. There's my building. Isn't it cute? There's my building. Okay, he's looking to the top of the building. And that angle of elevation is 40 degrees. Then it says, our Bill, he walks closer. How much closer? He walks 102 feet. And he looks up again. Pardon my straight line here. And that angle is now 50 degrees. What they want to know is the height of the building. All right. Well, some of the helpful things as you're doing this, or at least things to keep in mind, is that you want to make sure, okay, that when you're dealing with the law of sines, that you're working within the same triangle, okay? So you can't just say, all right, I'm going to do x is the sine of 40 as x is the sine of 50. That's not correct. We've got to work within the same triangles. And so this is actually going to require us to do a little bit of work here in terms of finding different parts of this. So to start with, we know the 102 feet, right? And so can I find some other information so that I can use it for later? And of course, the answer to that is yes. What I do know is the 102 feet. And so it would be helpful if I knew what this angle is. How do you find that angle? Think through that for a second. Well, we know this is 50. And what does that mean this angle has to be? It has to be 130 because we're forming a straight line. And so that's 180. And so if I add 130 plus 40, that gives me 170. So that makes this little itty bitty angle up here 10. So just to start with this, I would have 102 is to the sine of 10, right? Equals, and now I also know that 40 degrees. So the sine of 40, and that would give me this side. And do you see now what that would do is give me a side of this triangle, which would be very helpful. I'm going to call that y, just so you can recognize it. So I have 102 times the sine of 40 is equal to sine of 10 times y. And then I would have to divide by the sine of 10. All right, now I'm not going to get the answer for you. You're going to need to do that. You would have to obviously use a calculator, do it all up, right? You'd have to do 102 times the sine of 40 divided by the sine of 10. Again, making sure that your calculator is in degrees. But whatever we get for y, okay, we're going to use so that I can determine the height of this. See, I want to know that. So x is to the sine of 50. That's the angle that's opposite. And now, hopefully, you should know what y is, right? This you know from up here. And so I would do it to the sine. And what's the angle measure that's opposite it? It is assuming that that building is straight up and down. That is an assumption we do make. And so then you would do sine of 90, which we should know what that is, right? Because it's the same as pi over 2. So we know that that's just 1, isn't it? And so we have x equals sine of 50 times y, which again was the answer that we just calculated from up above. So that's what you have to do. And so for class and proof of your notes, I would like that answer.